Okay, so hopefully that makes sense. So that was a mistake I made there. So that's not 1.28, that should be 1.645. Apologies for that in that last video. So 1.645, just to quickly show you that 1.645 is the Z value for that. Okay, so 1.645. All right, so let's have a look at an example. So Mr. Smith takes a sample of 26 Year 12 students, and 18 of them intend on going to valedictory. So what we want to do is we want to calculate a 95% confidence interval, a 90%, it's just a bunch of different confidence intervals, okay? And one we're saying that is like for the value of P, okay? I should have put that in the question as well. All right, so let's have a look at this. Okay, so for a 95% confidence interval, our Z score is 1.96. Okay, so 1.96. Our N is our sample size, which is 26 students, and our P hat is our proportion that intend to go on the valedictory. So 18 out of 26, which is like a 9 out of 13. Okay, so that's our P hat. And so what that means for the confidence interval, so using our formula from up here, up there, where is it? There. So it's P hat minus all that sort of stuff. So here we go. All right. So our confidence interval, I'm just trying to squeeze it up here, is equal to our P hat, so 9/13ths, 9/13ths, take away Z, 1.96 square root of P hat, 9/13ths, times by 1 minus that, so that'll be 4/13ths, trying to write really small here, N was 26, right? So that's, I'm just doing that, and then 9/13ths take away, plus 1.96, same thing. So what you can see here is to save a bit of time, you could just find what the margin of error is, because that margin of error is just all that stuff there. And so if you found that first, then you could save yourself a bit of time. And when I do it on the calculator, I'll do that. Okay. So that's my confidence interval. That's my 90% confidence, 95% confidence interval. Okay. And I was about to say I won't do it on calculator, but I will. Should I? No, it's going to take me too long. Anyway, you just put that into a calculator, and that'll give you some values, small value and a large value. And what that tells you, right? If you put that into your calculator, what that tells you is that you're 95% confident that the value of P lies between this value here and that value there. And so that's what the meaning of it is. Okay. Yeah, I'm just trying to save a bit of time here. I'm just looking at that, and that's going to take me. You're going to watch me do the calculator for forever doing that. Okay. I'll show you something else in a second. So then a 90%. So if you're trying to find a 90% confidence interval, okay, what that refers to as a Z score of, what did we say for 90%? I had to change it, 1.645. Okay, so you would do exactly the same thing as before. Exactly the same thing as before, but instead of 1.96, you'd put 1.645 there and there as well. Okay, and so that's the only difference between those two. The most interesting one here is one that when it's not standard, right? So when it's 80%, you just need to think a little bit. Okay, and so just how would you go about doing this? You need to find what the Z score is for an 80% confidence interval. So if you got your P hat in the middle, and we want an area of 80% in here, right? 80% in the middle. So if we want 80% in the middle, you have to sort of think about what the Z score is. There's going to be 20% in the tails. So that means there's going to be 10% in the top tail and 10% in the lower tail. And so what the Z score will be, if you want to do that, then if we think about, I'm just looking for a different color, I'll go black. If we're trying to think what our Z score is there, then what's lower than that, so all that area below that Z score will be 90%. So what we do is we go to the calculator and we go menu, inverse normal, so probability 5, distributions, inverse normal, and we say what's the 0.9, that's the area below for a standard deviation of 1 and a mean of 0. So we're just trying to find our standard value Z, and that's 1.28. Okay, so 1.28. So our Z score here is equal to 1.28, and then we would do exactly the same as before, but just change to a different Z value. I'll just quickly show you how to do all these things on the calculator without having to do any of those calculations now that we've sort of done that, and I've refused to do it by hand. So you go to not probability, you go to statistics, and you're looking at confidence intervals. And what you want is number 5 there. You want your proportion Z interval. So that's the one we want, number 1 there. Okay. And so what you need to put in is your number of successes. Here, the number of successes was 18 successes. 18 successes out of 26. Can you see how it's not asking me for p-hat? It's asking me for number of successes. But it was 18 out of 26. That's what we want. And the confidence level was, let's say, it was 95%. It's already there, 95%. And it gives you your lower and your upper. And so you can see that there. And so what it's saying is that it thinks that the population proportion is somewhere between 0.514 and 0.8697 with a confidence of 95%. And you could do the same thing. I'll just put that in there. But instead, it's 18 out of 26. But instead of being 0.95, if you did an 80% confidence interval, it would look like that. And can you see how you've got a bit of a wider range for your confidence because you've got a lower percentage for your confidence because you're only 80% confident. So hopefully that makes sense. That's how you calculate those on your calculator, and so you don't have to do all these nasty calculations. But now you know how to do those things both ways. Hopefully that makes sense, and I'll see you in the next video.